this is going to be less than 4, and I'm going to, let's save as less than 4. I'm going to call this one begin floors. You'll remember from lesson 3 that we cut the outline of the interior face that was formed as a result of offsetting the exterior perimeter. That's pretty convenient to use to draw floor slabs. How so? If I turn off the visibility of these things and I tell SketchUp to edit paste in place, right? That's the shape, really it's the shape of that whole interior. If I take that shape, extrude it, say, a default 12 inches, triple click, make it a group, I could use that to represent each floor slab. So let me make a layer for that. Floor slab 1. And take that group and move it to floor slab 1. Technically, I could do something like this. Tap the control key, give it a value of 10 feet, and say 5x. So if we make 5 of them, then I can assign each one of them a component attribute for the elevation of where it's supposed to be. So if, say I wanted that one to represent floor 2. It's currently on floor slab level 1. If I add Z value without changing anything, it's just reporting that I placed it 10 feet above. So look at the CAD drawing. And from the CAD drawing, we know the second floor wants to be 12.7 above the first floor. So if the first floor is 0, second floor can have the value of 10.7. Looks like some of these floors are different elevations, meaning there might be a modulation of the floor slab inside. For now, we're going to ignore that. And we're going to choose simple values that we started with. So I'm going to say 11.5 and then add 10.6 3 times to give us each subsequent floor. So this is going to get a value of 11 feet 6. And I'm going to make a layer for floor slab and place that, change that to floor slab 2. I'm going to take the third, give it a Z value, 11.6 plus 11.5 plus 10.6 is 21.11. Put that on floor slab 3. Select this fourth one, 21.11 plus 10.6, right? 21.11 plus 10.6 is 31.11 plus 32.5, right? 32 feet 5 inches. And that is 1, 2, 3, 4, right? You need a layer for it. Floor slab 4. Move this to floor slab 4. Finally, we had one more than we needed, right? So let's delete this one. This is floor slab 5, and that's going to be 10.6 above 389 inches. I'm going to have to calculate that. Wow, calculator. 389 plus 10 times 12 plus 120 plus 6. 515 inches. So that one is going to get a z coordinate 515 inches. What's 515 inches? Divide that by 12. 42. 4210 more or less. Right? So at this point, what have I got? Walls, slabs, if I change my style visibility to X-ray, we've pretty much got the outline of the building without the roof. There's a bit of ornamentation, and we haven't modeled openings and all the other systems that go in there, but for the most part, we have a good deal of the building. Let's look at this in the context of the elevation. Just turn on like the south elevation. I'm going to take it and move it inside the building and see what that tells us. It's okay to do that. I mean, these things are here to help understand. It looks like the floor slabs pretty much correspond to what they're supposed to with the elevation markers, right? We still have to make openings. So what is this telling us? Well, it's telling us that the tower needs wall system that's an additional height. We are going to need one more floor level, and that floor level is going to represent, think of it, this is going to be the underside of the roof. So I'm going to take that slab, that last one, drag it in the blue direction, tap the control key. It snaps to 10 feet, which is about where the roof starts. So that's going to be my attic slab. So I want to say, create a layer for it, floor, slab, roof, or underside of roof. And then take this slab and move it to floor slab roof. And that's where my tower walls are going to start. Does that make sense? So technically, if I turn on the AutoCAD roof drawing, the walls that form the tower can begin at being drawn on that level. Maybe I'm not going to use the roof plan to draw them. Maybe I'm going to use a floor plan, any one of the lower level floor plans. Let's turn off the south elevation drawing. Go to a top view. Because I want to be drawing on this level, I can turn off the visibility of the floor slabs below, and I think I can ascertain what the outline of the floor ought to be. I'm using the underlay of CAD Drawing 1. Let's see if the 0 gives us anything better. Not really. So let's use AutoCAD Floor 1. Right? And I'm basically going to draw from here, these endpoints, I missed that. So that's the outline of the tower footprint, right? If I offset it 2.5 feet, 2.5 feet, that's going to give me the shape of what my tower height is going to be. To be clear about that, let's turn off everything that we can see below this. See what I've done? I'm going to cut that to the clipboard, and that's the shape of the tower. Now, what's the height of the tower? Go look at the CAD file. We could turn it on in the model, but we have it open, so let's look at the elevation. So the height of the tower walls are, let's go ahead and measure from this point. Linear dimension. I'm going to use that point, and the height is going to be to the to the eave of that roof. That's going to be 30 feet. 30 feet 2 inches. We don't have that level of precision, right? So if I take these walls or that shape and extrude it to a height of 30 feet 2, triple click, make it a group, create a layer for walls, exterior tower perimeter. Layer names are a little verbose, but it's just so that we're clear about walls, exterior tower perimeter, right? So if I turn off AutoCAD and now just turn on geometry that I'm modeling, you see how that works? And the floor slabs, 1, 2, 3, 5. Now all that's left to model is the shape of the roof itself. So I'm going to save out that lesson, this 15-minute lesson. begin floors and tower.